Every morning, you do something kind of amazing without even thinking about it. You get dressed. But here's the catch. You can't just throw everything on in any order. Some things have to come before others. And that's not just about clothes. Whenever one thing has to wait for another, building a house, recalculating a spreadsheet, it's the very same puzzle. And it all comes down to one question. What can you actually put on first? Let's figure it out together. Okay, let's start with just two of them. Socks and shoes. Which one comes first? What if we said shoes, then socks? No, that's backwards. Socks always go on first, and then the shoes. And that little arrow is just how we write the rule down. This one comes before that one. Now the rest are easy to spot. Underwear goes before pants, and the pants before the shoes. And up top, the shirt goes before the jacket, and the shirt before the watch too. Take a step back and look at what we just built. This whole picture has a name. It's a directed graph. Each piece of clothing is a node, and each arrow is a dependency. It points from the thing you put on first to the thing that comes after. Remember the question we started with. What can I put on first? Look at the graph, and it's right there. The things you can start with are the ones with nothing pointing in, nothing they're waiting on. Your eye catches those in a second. A computer can't. It needs a rule it can follow every single time. And it all starts with one number. For each piece, we count the arrows pointing in. Take the socks, nothing pointing in, so that's a 0. The underwear, 0 too. And the shirt, 0 as well. Everything else, though, is waiting on something. The pants, 1, waiting on the underwear. The shoes, 2, with the socks and the pants both ahead. The jacket, 1 from the shirt. And the watch, 1 more, the shirt again. Now every node carries a number. How many things it's still waiting on? And that number has a name. It's in degree. And the 3 sitting at 0 have nothing to wait for. That's where we start. Here's the plan. Every node at 0, every node with nothing left to wait on, goes into a queue, our line of things that are ready. And over on the right, we build the final order. Start by tossing in everything that's already free. Socks, underwear, shirt. Grab the first one, the socks, and put them on. The socks were holding up the shoes. So that rule is finished. We cross it off, and the shoes drop, from waiting on 2 down to 1. Next, the underwear goes on. That was the only rule the pants were waiting on. So, clear it. Their count drops to 0. The pants are free, into the ready line. Then the shirt goes on. The shirt was holding up 2 rules, the jacket and the watch. Clear them both. Both counts fall to 0, so both are free now. Now the pants go on. And that clears the shoes' very last rule. Their count finally hits 0, so the shoes are free too. And from here, it just falls out. The jacket, the watch, and finally the shoes, each already free. So on they go, one after another, until you're fully dressed. And there it is, fully dressed. Out of that whole tangle of rules, we found one clean order that actually works. And that order we just built, where every arrow points forward, nothing out of place, has a name. It's a topological sort. And the method that got us there, always take a node whose in degree is 0, put it on, then update everything it was blocking, that's Kahn's algorithm. But this was never really about getting dressed. That same move, untangle what depends on what, then find an order that breaks no rules, is how anything big gets built. Think of a house. You can't hang the drywall before the wiring's in. You can't run the wiring before the frame is up. So the whole schedule gets sorted, exactly like ours. Same idea, just hundreds of steps instead of 7. So the next time you get dressed, socks before shoes, know that the very same untangling puts up the buildings around you.